Ahoy there, mateys! I be recording this video on September 19th, which be International Talk Like a Pirate Day. So, ahoy! There'll be rough seas ahead. Chapter 8, Section 1, Question 1, the square root property. Now the important thing here is to use the square root property, not to use factoring. So, many of you have used square roots on both sides of an equation before, but often you have not used a cool symbol called plus or minus. You'll see why it's called plus or minus in just a moment. So, in algebra, we add 200 to both sides. That is a very strange looking zero over there. Fixing zero, whee! And you get x squared, equal signs beautifully lined up, 200. And then, what we're going to do is we're going to square root both sides of the equation. But when you do that, we must have a special symbol, plus or minus. And we will get x equals plus or minus the square root of 200. Back in chapter 7, we learned how to simplify a square root. So if we think about 200, we can break that up into 2 times 100. The 2 comes down, and 100 breaks up beautifully into 10 times 10. And those multiply. We have a pair on the inside that comes outside once, and then the 2 stays on the inside. That is from chapter 7. Yay! That is a perfectly fine answer for our class. However, some of the college professors and the program called My Math Lab that the colleges use would like you to write it as negative 10 squared root of 2, negative answer first, comma, positive answer second. So, hey, for our class, if you want to get prepared for the next class, so showing work, I absolutely need to see this in this section. If you do not have a square root on the left, a square root on the right, and that plus or minus, I am taking off at least a half point from your problem, because this shows that you understand what the square root property is you square root both sides, and on the non-variable side, you put the plus or minus. Continuing on. This time, we're going to subtract 200 from both sides. From chapter 1, we are using the additive inverse, meaning the opposite of addition is subtraction. We get x squared equals, this time, knowing that I'm going to have to put that plus or minus square root, I'm going to leave a lot of space here. Take a look at all this space that I have, so that when I square root both sides, I have the space to put the plus or minus. Now, I've seen some students who don't have the space, and what they do is they put the plus or minus in the index. The index number should never be negative. They put the plus or minus on top of the equal sign. That doesn't make sense either. So make sure that you have the room to put it after the equal sign and before the square root. That's where it goes. Let's see. We have the plus or minus. The square root of 200 we already know is 10 square root of 2. But wait, what happens with the negative on the inside? In chapter 7, section 7, we learned about imaginary numbers and complex numbers. With that, a negative on the inside comes outside as the letter I. Again, this answer, perfectly fine for this class. But to prepare for college, we want x equals negative answer first, comma, positive answer second. Showing the work on both sides of the equation, so we make sure that we do that to both sides. You rewrite it, you square root both sides with the plus or minus on the non-variable side. If you do not have this step here, I will take off half point. We rewrite it and simplified radical form on all of these, and this step here is if you would like to prepare for going into college. Interesting follow-on to chapter 8, section 1, question 1. So, if I have x squared minus 9 equals 0, back in chapter 5, we solved this. We can factor it, so why would we do it this way? Well, part of it is because we don't want to factor these, those are gross. And we would get the answers x equals negative 3 and positive 3. Hey look, those are the two answers. Now let's take a look at how we would do it here. X squared minus 9 equals 0. We would show the work to add 9 to both sides of the equation, making sure to do it to both sides because algebra. Leaving that space here in front of the number so that you can put the square root with the plus or minus. Many teachers in the past only taught you to square root. They didn't teach you to plus or minus square root because often in the past, the only use for this math here was to solve for the side of a Pythagorean triangle, right triangle, and your teacher knew that the answer had to be positive. In chapter 7, we went over the fact that there's a positive answer and a negative answer, but because of the chapter 5, you can't have a side that is negative, we crossed out the negative answer. But in chapter 7, I made you find both of the answers using this method because you should know at this level of math that there are two answers. There's a positive 3 and a negative 3, and that is why you will get plus or minus 3. That's why this is correct. Many teachers in the past didn't teach you that because you didn't need to know it yet. Now, you need to know it. So, here it is. Chapter 8, Section 1, Question 2. It's the square root property again. We're going to keep using this for much of this chapter. So here we go. Use the square root property to solve each equation. Notice that we have isolated the squared term, so we will then square root both sides of the equation, and on the non-variable side, we have to put in our little plus minus. Gosh, that didn't seem to fit there very well. I guess I had better rewrite it to make sure that this fits nicely. So, I'm going to copy this, equal sign, leave a space, and then the 16. That is a very exaggerated space because, hey, this is our lesson so that we can make sure you can put the plus or minus and the square root without squishing it into the equal sign or putting it in the index number. That would be wrong. This is the key step to using the square root property. If you do not have this done correctly in this section, half point down. Not good. The square root from back in chapter 7, we started learning this, that the square and the square root cancel, leaving us with x minus 3 equals the plus or minus 4. Yay! Now, from here, we're going to make two equations, kind of like we did in chapter 2 with our absolute value equations. Now, think about this. In chapter 7, we did this, and we put absolute values on it in 7-1. The absolute values are what make the plus or minus also. Think about that. All right, so we are doing an absolute value equation, in which case, instead of having the absolute values, we're just going to write x minus 3. We want the negative version on the left, and x minus 3, we want the positive version on the right. And by doing it this, boop, that was an equal sign. That was a negative. There we go. We get to do the same thing to both sides because that's what happened with our absolute value equations back in chapter 2. And hey, those are our answers. That's pretty neat. Over here, oh no, that x squared term is not isolated. We must isolate it. So the plus 18. We need to subtract 18 on both sides. Leave a space. Hey, leaving a space is going to save you a lot of points here. We're going to square root both sides. We must square root the left side and plus or minus square root the right-hand side. It's not necessarily the right-hand side. It's the side that doesn't have your variables on it. That's the side that's going to get your plus or minus. From back in chapter 7, section 1, the squared and the square root will cancel out, leaving you with x plus 2 equals plus or minus, oh dear, that does not come out nicely. Let's take a look at 18. 18 breaks up as 9 times 2. 9 breaks up as 3 and 3, and we bring down that 2. I have a pair of 3's. They're going to come outside once, and the 2 is going to stay on the inside. But wait, that was negative. We think back to chapter 7, section 7. A negative on the inside comes outside as the letter I. Interesting thing. This is particularly yucky. So, we have x plus 2 equals the negative version of 3i square root of 2, and x plus 2 equals the positive version of 3i square root of 2. We're going to subtract 2 from both sides. We're going to subtract 2 from both sides. And the important thing is we can only combine like terms. If you remember from chapter 7, section 7, when we were learning about the imaginary numbers, we had a plus bi form. That is never going to go away. So the real number goes first, and the imaginary number comes second. The real number comes first, and the imaginary number comes second. There you have your two answers. But wait, there's more. Now, for the purposes of this class, because you can't combine those, I would actually let you do a I'm not in college algebra yet method. But be careful. For those of you who are going on to college algebra, this is not going to help you. What you would get is -2 plus or minus 3i square root of 2. I would accept this answer on this problem instead of the answer that is split up. Now, the question is, hey, Miss Jordan, if I had this, would you then, by the same reason, accept x equals 3 plus or minus 4? No, I would not, because you can do 3 minus 4, which is -1, and you can do 3 plus 4, which is +7. So, no! I need the actual answers here. This came out awfully nicely. So if someone said, couldn't I just multiply this all out, get it on one side equal to 0, factor it, and solve it? You could. Could you get the right answers? Yes, you could. Would it be by completing the square and using the square root property? No, it would not. Folks, we have to use the square root property. That is what we are learning in this section. This here, square rooting both sides, that is what is important for us to learn this section. Chapter 8, Section 1, Question 3. Completing the square. Ladies and gentlemen, we're going to learn a lot of ways to solve something like this. In fact, you've already learned some ways back in Chapter 5. But we are going to learn completing the square because you're going to see this in Chapter 8, Section 1 this year. You're going to see this again, slightly differently, in Chapter 8, Section 5. It is in Chapter 1 of our college algebra class. It's one of the first things that we go over there when we're going to be covering how to complete the square and find the equation of a circle graph. These, being x squareds, these are parabolas. You'll still have to know about parabolas in your college math. But also, there's going to be Chapter 6, I believe, in your 121 class, where you're going to have to know about completing the squares. That's almost the entire chapter. We're learning this for a reason, because I, with my futuristic strength, am showing you where we're going to have to need this in the future, and that this is an important thing to learn. So the first thing we do is we're going to isolate just these x terms, which means that, hey, this 15 is going to get moved over to the right-hand side. Boing! There it is. Now, we have to find what number goes into these squares. I think that it's cute to have completing the square done by adding a square to the left and a square to the right. Because in algebra, if you add something to the left, you should be fair and add something to the right. Now, how do we figure out what goes in these squares? We're going to use a formula that says b over 2, the whole thing squared. Do you remember that over here, a is equal to 1, b is equal to -2, And I've been telling you since chapter 5 that we want this first term to be positive. Folks, we want that first term to be positive. In fact, in this case, we always want that first leading coefficient to be 1, and that's it. If it's not 1, your lives will be much harder. Will this happen in your college class? Absolutely. Am I going to cover that right now? No. This is the level we're covering right now. Right here. We're going to do b divided by 2 squared. That's what's going to tell us what goes in here. One of the college professors requires her students to write b over 2 parentheses squared and then plug in negative 2 over 2 parentheses squared. That is enough for her to understand that you know what you're supposed to write in there. But let's take the time to do this. Negative 2 divided by 2, that's negative 1. Squared, negative 1 times negative 1 is positive 1. I'm going to put a positive 1 here and here. I have to do the same thing to the left side and to the right side. This is a little bit different from chapter 8, section 5, because what's going to happen there is instead of adding 1 to both sides, we're going to take this 1 over here, move it to the other side where it will be a plus 1 and a subtract 1. That's coming later. This is what we're doing now. So, to recap, we moved the plain old coefficient, the c number, over to the right-hand side. We took the b number, we divided it by 2 and squared it. I do not require my students to show this work, but I think it really helps. And since one of the college professors was requiring her students to do it, hey, you might do it, because it really is a good idea. Now, we're going to factor this side. You do not have to put a swoopy thing under here. This is a perfect square trinomial where you look at here, here, and here. X minus 1. Boink. Then, you do not have to put a swoopy thing over here. You're going to put these two together. 15 plus 1 is 16. Does this look familiar? It should. It should look just like the problems we just did, which required the square root property. That's why it's in chapter 8, section 1. We're going to do the square root property where we square root the left, we square root the right, and wait. What do we have to remember? When we square root both sides of an equation, we have to remember plus or minus. Notice, hey look, it's on that side of the hook part, so it's not in the index number and it's after the equal sign. These are the things that I will be checking for. Keep that in mind. The square and the square root, just like in 7.1, cancel out. We get x minus 1 equals plus or minus 4. Two equations. X minus 1 equals the negative version. X minus 1 equals the positive version. Just like in chapter 2 when we were doing absolute value equations. And we do the same thing to both sides. We do the same thing to both sides. We use the additive inverse from back in chapter 1, and we find that the answers are x equals negative 3 and x equals 5. Hey look, those are our answers. 1, 2, yippee skippy, yay! Those come out very nicely. Isn't that neat? But wait, let's take a look at this. I told you that we have learned many ways of solving this. This is one way. Gosh, that was long. But wait, didn't we, back in chapter 5, learn a different way to solve this? Why, yes, we did. We broke up x into x times x. We broke up 15, usually in our heads, into either 1 and 15 or 3 and 5, and checked to see which of these numbers subtract to give me negative 2. That would be these numbers. How does it get me negative 2? Well, that would be a positive 3 and a negative 5. How does this factor? It factors into x plus 3 and x minus 5. Make sure you have that equals 0. That's what says to keep going and not just factor. And then I can equal 0. Why can this equal 0? From back in chapter 1, we had the multiplicative property of 0. If things multiply to equal 0, something has to equal 0. So either I can equal 0 or I can equal 0. Somebody has to equal 0, and we are solving them. And we get x equals negative 3 and x equals 5. Hey, that's the exact same answer we got down there. It's like math works. Now, students have said, hey, well, since math works, obviously it doesn't matter which method I use to solve. Yes, it does. Why? Because the instructions say, solve for x by completing the square. If you find the answers, but you don't complete the square, I will give you half credit for finding the answers. Good job. But I will not give you 100% full credit unless you complete the square. Completing the square will include this square root property, which is going to be in every single problem for 8.1. So make sure you do it this way. Chapter 8, Section 1, Question 4. Completing the square again. All right, so once again, see all these that have x's? We want to leave them on the left-hand side. It is important that this be 1, and we like that this is even. That's going to make it easier for us this year, but next year they won't be even, and you'll see why that is important. We're going to isolate those. We're going to move these 7s over to the other side. Now, how do we fill in this box? Those are squares. We want to complete the squares. That's why I have squares. One of our college professors, all he wants is an underline here. Another college professor says to write down the formula, b divided by 2, the whole thing squared. So if we look at our b number, that is 10 divided by 2, the whole thing squared. I do not require you to do this, but it is a wonderful, wonderful idea. 10 divided by 2 is 5. 5 squared is 25. We're going to add 25 to the left-hand side, and to be fair, we're going to add 25 to the right-hand side. Why do we do that? Because in algebra, you do the same thing to both sides of the equation. That's a legal move. We're going to look at the left side, and we're going to factor it. Remember, perfect square trinomial. You break it up, you break it up, you break it up. X plus 5, the whole thing squared. X plus 5, the whole thing squared. Negative 7 plus 25. Negative, okay, so hey, what's 25 minus 7? That is 18. Notice again this lovely space here, because we're going to have to use that square root property. Here we go. Square root on the left, square root on the right. But wait, something's missing. When you square root both sides, what do you have to remember? You have to remember the plus or minus. And remember that the reason we left that big space is it goes after the equal sign and before the hook. I hope you are watching this video, because otherwise you're probably going to lose some points on this. Square and square root, just like in Chapter 7, Section 1. You are left with x plus 5 equals plus or minus. Wait, there's something I can do with 18. Let's take a look. 18, hopefully you already know this, but that breaks up as 9 times 2. 9 breaks up as 3 times 3. Bring that 2 down so that every line equals the line above it or the line below it. I have a pair of 3's, and the pair of 3's will come outside once, and that leftover 2 is a leftover 2. Are we done? No. Why not? Because we're solving for x. X is not all by itself. Now, I told you that for this class only, you are welcome to shortcut. Because this came out yucky, you may subtract 5 on both sides and say x equals negative 5 first and plus or minus 3 square root of 2 second. The square roots and the plus or minus, those are the second things. I would accept this answer, but I would rather you prepared for college. So therefore, what I would like to see is x plus 5 equals the negative version first. X plus 5 equals the positive version second. Subtract 5 on both sides. Notice that I'm not lining it up. I don't want you to accidentally combine like terms and get like negative 8 square root of 2. That would be horrible. So you would get a negative 5 first with the minus 3 square root of 2. And then you would get the negative 5 first with the positive 3 square root of 2. And be careful what I just said. Don't combine these. This has a square root of 2 attached to it, and that doesn't. They are not like terms, and they can't be added together. This is the answer that we're looking for, because this is the answer that prepares you for college. This is the answer that is okay for this year. If you want to do it like that, I'll still take it. But, hey, part of my job is to prepare you for college. That's how we're doing it. For this question, I have in the lecture notes a version of this problem that looks forward towards 121, and also a question that helps you to derive the quadratic equation, which is next section. Unfortunately, I'm not going over it right now, so sorry. But if you are interested in that, those are questions that are important for 121, our college algebra class. If you'd like to take a look at that, it's in our lecture notes.